Okay, exercise 14N, question 1b. Now this actually had me going in circles for a bit, so this is the sucker here. This one, let's have a go at that. Right, so looking at this, just writing it out, so we've got 2 cos of 3x equals root 3. Now, looking at this, we would consider using the general solution formulas. So just to refresh your memory on those, there they are there. Now, to begin this, the way that I approached it was actually do something a little different. I was getting confused between the x's in the general solution and the x's in this one, so I'm actually going to cheat a little bit, and the formula we're going to use will be the cosine one, so this one here. And I'm actually going to write it with a y just to make sure I don't get mixed up. So we write the formula, general solution for cosine, as y equals, so rather than x we're using y, so y equals 2n pi plus or minus inverse cos of a. Okay, now we also know that the cosine of, now remember we're using y here, cosine of y is equal to a. Now we're given that 2 cos 3x equals root 3, or writing another way, cos 3x is root 3 over 2. Now this is where the penny dropped, for me at least, in that in this case the y there is equal to that, and the a that's there is equal to that. Once I got that step, it all seemed to make a bit more sense. So just scrolling up. So we can say that 3x equals, now we'll take the inverse cosine of both sides, so to get the 3x on its own, take inverse cosine of the left hand side. That means we have to do the inverse cosine of the other side. Actually, no, back a step, sorry. Looking at this formula here, we've got the a, and we've also got the solution, in this case given as a y. So we can actually look at these things now. So we've got the y is 3x, so we can rewrite that general solution as 3x equals 2n pi plus or minus inverse cosine of 3 over 2, because what I've done there is said that that thing is that, and obviously that thing is that. There's the a. Alright, so that's how, whoops, I brought it all together. Now what we can do is, with our exact values table, and just to remind you of that, my cursor here, looking for root 3 over 2 in this table, so it's in here, and we're dealing with cosine. So we've got cosine there, root 3 over 2, looking across, turn that back into an angle, pi on 6. Because effectively we're using the exact value table to find the inverse cosine. In other words, we've got the cosine of the angle, we want to get the angle itself. Right, so we're much closer now. So we can rewrite this as 3x is 2n pi plus or minus inverse cosine 3 over 2 is pi over 6. Okay, just a bit of manipulation, get x on its own. X is equal to 1/3 into 2n pi plus or minus pi on 6. Multiplying that out, we've got 2n pi over 3 plus or minus, and just leave the plus or minus there. It's still a valid operator. Pi over 18, scrolling up, and a bit of fraction work. So common denominator 18, 3 is no 18, goes 6 multiplied by 2 and pi plus 18 into 18 goes 1 times pi, oops, plus or minus in there, which is 12n pi plus or minus pi over 18, which we could leave it like that, but the book has actually taken a pi over 18 out. So in here now we've got 12n plus or minus 1, and that's the answer.